We are finishing up Unit 4, which means that a test is coming next week, probably on Wednesday or Thursday. What we're doing today are real-world problems. These can be pretty difficult because there is no set, this is exactly what you do in every single problem. You really have to read the problem and just think about it in a real life context to see what it's actually asking for. The biggest problem comes when you are having to decide, are you finding one single term or do you need to find the sum of several terms? Usually that's where you can have some issues. So the way I've set these problems up is to kind of guide you through getting to your final answer. These are kind of the steps that you should do every time, even if I don't ask you every single step. Like if my question is just find your answer, you should be doing all of these things every single time. I am going to kind of skip around and not go in the exact order that these are in, just because. So if we start with number 1, we have Callie's New Year's resolution is to work out each day on her elliptical. She burns 349 calories the first day and plans to increase that number by 8 each day. And our goal is to find the number stick to her plan. So the first thing that we need to do is create like a little table that's going to help us, or even just list out the first few terms. So I've got a table for you. It's by days. So day 1, day 2, day 3, and so on. So like day 1 is your first term. That's A1. So like this is A1, A2, A3, and A4. And we are calculating a number of calories. So it tells us on day 1 she burns 349 calories. And she's going to increase that number by 8. So how many calories is she going to burn on day 2? 357. How many is she going to burn on day 3? 365. 8 each. Now, once you've kind of figured out the first few terms, then you should decide, okay, are we looking at arithmetic or are we looking at geometric? Are you adding the same number from one to the next, or are you multiplying? Which one are we doing here?
Adding.
You're adding, so we know that it is what type of sequence? Arithmetic. So it's arithmetic, which means we have a common difference. And what is that common difference? 8. Now our goal is to find the number of calories she is going to burn on the 30th day. So the first term is the number of calories on day 1. The second term is the number of calories on day 2. So if we want to know on day 30, are we finding just the 30th term, or do I need to add all of these together? It is just the 30th term. Right? And that's because it's only asking for the 30th day. If we were going to find a sum, it would say, what's the total number of calories she has burned over the first 30 days? That would kind of be how the wording would be. Right? So every sequence has a formula that goes with it. We know that arithmetic, I'll give you the formula again. A1 plus D times n minus 1. And when you are asked to find the explicit formula, you need to actually plug in your A1 and your common difference. What is A1? 349. What's your common difference? 8 times n minus 1. When you are just asked for the explicit formula, it is a generic formula. We are not plugging anything in yet. Okay. So like on the test, if it says what is the explicit formula, there shouldn't be a number plugged in for n. Now when it goes to actually finding the final answer, we are finding the 30th term. Do we need sigma for this? No. So we're just going to do 349 plus 8. And then 30 minus 1 in parentheses. And then you can type that in your calculator. For right now, you can use these handhelds just because it's too much to have your Chromebook out. On the test, it will be on the Chromebook and you'll do everything through Desmos. Okay, but for now, we'll just use these. And so we get 581 calories. Does that number sound reasonable for the problem?
Yeah.
You should always ask yourself that. I mean, if I had like 5 million, okay, that would be a little suspicious. If you had like 5.7, that really wouldn't make sense either. So try to think, does this make sense for the problem? All right. We'll go ahead and move to number 2. An auditorium has 14 seats in the first row, 16 in the second, 18 in the third, and so on. How many seats are in the auditorium if it has 30 rows? That's our goal. So we're going to take it step by step. We're going to fill out the table first. So we're looking at a number of rows. So row 1, row 2, row 3, row 4, and the number of seats. So finish filling out that table. Really, honestly, that shouldn't be number of rows. It should just be row 1, row 2, row 3. Okay. So row 1 has 14 seats. Row 2 has 16, 18. What about row 4? 20. Okay. How did you get 20? You figured out you were adding 2, which means it has to be what type of sequence? Arithmetic. Right. So, term 1 is how many seats are in row 1. Term 2, that's how many seats are in row 2. And then you're going back. How many seats in row 3? Our goal is to find out how many seats are in the auditorium. So and it does tell us up there the auditorium has 30 rows. So are we looking for the 30th term, or are we adding terms 1 through 30? You're adding terms 1 through 30. Just the 30th term would be just how many seats are in that row. But we want to know the whole auditorium. So you got to count up all of the seats in the first row, all of the seats in the second, and add them together. So we're going to be doing the sum of the first 30. Now, if the question had said, how many seats are in the 30th row, that would have just been the term. So you really have to look and pay attention to what the question's asking. All right, what is the formula that goes just with this sequence? Because we'll need that. We're not using sigma yet, but what's the formula? Yes.
14 plus 2 parentheses minus 1.
Yes. Yep. AN equals 14 A1 plus common difference is 2 times n minus 1. You need that formula because I could ask you like 10 different questions about this one, and you will use that same formula for every question. Now our final answer we need to do is to actually find the sum of the first 30. So sum means I need sigma. What goes on the bottom? N equals 1. What number goes on the top?
30.
And again, am I doing the first 30?
Figure out how many seats are in the auditorium.
That's how many rows are in the auditorium, yeah. Like, it stops at 30, so I'm not going to keep adding past that. And then we do 14 plus 2 times n minus 1. On your 84 calculators, you're going to do alpha window. That on the 84s, alpha window has a lot of symbols. And so if you're ever needing some kind of weird symbol, that would be where you would check first. So alpha window. Now, and then you see it's number 2 there. Now it doesn't put a letter in the first blank. You can do an N, but I find that it's easier to hit this button by the green one. It's gonna put an X there when you hit that. That's fine. You don't have to use N as long as you use X over in the formula. That just saves you some clicks. Okay. It shouldn't have. Clear it out and then go back to do alpha window. Okay, X. Hold on. We'll say alpha window 2. To get the X, this one right beside of the alpha, it has the first thing that's on it is an X. So I hit that. And then it moves you over automatically. Then you put a 1. You would have to arrow up to type in a 30. And then you go over here. Notice on the calculators, it already gives you those outside parentheses. So I'm just going to do 14 plus 2, and then I have to do more parentheses, x minus 1, and close those. And hit enter. Okay, let me look at yours. Alright, and we get 1,290, and this is seats. Are there any questions on that example? Alright. Let's see. I'm going to move and go down to number 4. I told you I'm going to be skipping around. Okay. Let's go and do number 4. Jameson opened a savings account with $1,500. So he literally walks into the bank with $1,500, starts his account. After 1 month, his balance is $1,545. So we're looking at a number of months and his balance. Okay. So after 1 month, his balance is $1,545. After 2 months, his balance is $1,591.35. After 3 months, his balance is $1,639.09. So We're going to be finding his balance after a year. So what number do you think should go beside of that 1? 1545, yes.
Couldn't you use 0 and 1500?
Yes, yeah, you could have. So in month 1, it's not 1500. Like, that's what it started with, but we're looking at after the full month is up, he's at 1545. Now, sometimes you could put a 0 there and have the 1500, like your 0 term. That's possible. There's some other examples through here that is similar, where the term that it gives you is more like the 0 term. So that's kind of why I'm skipping around. So after month 2, it's the 1591.35, and then 1639.09. Look at these numbers, play around with these numbers, and see if you can figure out if it's adding the same thing every time or if it's multiplying, and what that number is that it's adding or multiplying. Now these numbers get into some decimals, and so you probably right off the bat couldn't figure it all the way out. So to check to see if it's arithmetic, you take one term and subtract the one before it. And we'll do that to see if we get the same thing. So for example, 1591.35, we subtract the number before it, the 1545, we get that number. And now let's check 1639.09 minus the one before it. Are those numbers the same? No. They're kind of close, but not really. So let's check to see if it's geometric. 1591.35 divided by the term before it, we get 1.03. Okay. 1639.09 divided by the one before it. Not exactly the same, but pretty close, right? Like, that's 0.029999. So basically, I think those match up better than the others. If you look, if we take 1591.35 and times it by 1.03, it's just because it was rounded. That's why it wasn't exactly the same. Okay. So that tells us that it's got to be which one? Arithmetic or geometric? Geometric. And so the R would be what? What was that number? 1.03. Mm-hmm. Okay, so let's think about what we have here. First term, that is the balance after the 1 month. So basically think Jameson got on the app on his phone and it was 1545. At the end of February, he checked and it said balance 1591.35. At that point, does he need to say, well, in January I had 1545, so let me add those together? No. The second term is his new balance. After the 3rd month, he opens it up and it says the balance in month 3 in March is 1639. At that point, does he need to go back and add the previous 2 months to it? No. When you look at your balance, that is the amount of money you have. You don't add what you had last month because you probably spent money, added money, all of that. So if we are finding the balance after a year, am I finding one term or am I adding terms together? No. Month 1, that is your balance. Month 2, 1591 is his balance. He does not go back and add that to month 1. In month 3, the 1639, that is his balance. You do not go back and add. And that continues. When you get to a full year, and you open it up and this is your balance, you don't go add January plus February plus March plus April, May, June, July, August, and so on. You just look at that current balance. So we're just looking at one term. Now what term is that? After 1 year? 12. Because we were doing this by months. So 1 year is 12 months. So we are finding the 12th term. A way that this could be worded where it would be a sum is if it said in month 1 he added 1545, and then in month 2 he put in 1591. Then you could be doing a sum. But this is his individual balance, like those months. Okay. So the formula that goes with that, it is geometric. So we have, what is A1? Times, it's geometric. What is our R? And then where does the n minus 1 go? In the exponent. And to find just the 12th term, we do not need sigma. We only need sigma when we're doing a sum. So we're going to do 1545 times 1.03 to the 12 minus 1 power. $2,138, $2,138.64. So that one was a little tricky. Usually, like the money, talking about balances are kind of the more tricky ones where you have to think, do I need sigma or do I not? Okay. Alright, let's see which one I want to do next. Right. Let's go to number 6. A company is offering a job with an hourly pay of $18.75. So that's what you get an hour. But you plan to get 65 cents after every year of working. So you work a full year, they're going to give you a 65-cent raise every year. Assuming we take the job, we want to know how much we'll be making per hour after 15 years. So when we make our table, this is the year, this is the pay. So remember, you're starting as $18.75. Our first term, that is after year 1. So after year 1, how much are you going to be making? Is it going to be $18.75? No, because we're assuming after year 1, you've got your raise. So what would the pay be after year 1? What is it? 1940. Okay. And you got that because you added the 65 cents on. What would year 2, what would your pay be? And then 2070, 2135. All right, so is this arithmetic or geometric? Arithmetic. And what's the common difference? 0.65. Yeah, 0.65. we want to know how much you're going to be making per hour after you've been there 15 years. So are we going to find the 15th term, or are we going to add up the first 15? 15th term. If you add up the first 15, that's going to be a lot of money that you're making per hour. Probably not realistic, right? Like you don't, after year 2, you're not like, oh, at this point I'm making $39. Ooh, at this point I'm making $69.45. No, it's each term is how much you're making for that year. So it is just the 15th term. I want you to finish parts D and E. So it's arithmetic. So your formula, you start with A1 plus your common difference, and then the n minus 1 is right beside of it. And we're just finding the 15th term, so we would just put a 15 in there. And 28.50. That's how much you'd be making after 15 years. Alright, let's go down to number 8. Evan is participating in a 24-hour dance-a-thon as part of a fundraiser. What that is basically for 24 straight hours, you got stuff going on and you're doing different things to raise money. So Evan raised $50 in the first hour. So like if he's got a box where he's putting his money, in the first hour $50 went in that box. In the second hour $60 more went in the box. In the third hour $72 went into the box. And we're collecting all of this money. That's not saying each of these is not how much is in, it's not the total amount in the box, it's how much he added to it. Okay, so like after hour 1 he goes in and places in $50, then he say, oh, I got 3 20s, let me add to there. And then he had $72 and he put in there. So that's important to know that when you're thinking about, is it one term or is it a sum? So this is the hour, this is the money added. So after hour 1, it says he raised $50 in the first hour. In the second hour, 60. In the third hour, 72. We want to know if this is arithmetic or geometric. This one's pretty easy to narrow down because if it's arithmetic, from 50 to 60, what does that go up by? 10. Does it go up by 10 again? No. So it can't be arithmetic. So it's probably going to be geometric unless somebody made a mistake. So go ahead and see if you can figure out what that common ratio would be. Go. What did you say, 1.2? And so that sounds about right. Let's see. So to figure it out, you can take one term divided by the one before it. And we can check here. Yep. You can see that it's 1.2 both times. So we would say it's geometric. And our R would be 1.2. So now we need to decide, am I finding one term or am I adding a bunch together? Okay, what does it ask? What is the final go asking us?
How much money you will have by the end of it?
What's the total amount we've raised? So how much money is in the box? Well, we want to know after the full thing, which is a full 24 hour. It's a 24-hour thing. So we have the first 3. We want to know how much is in the box after the full 24 hours. So, am I doing the 24th term or am I doing sigma? Keep in mind that each term is a new amount added to the box. So it is going to be sigma. Yep, this one, because this is 50 going in the box, 60 going in the box, 72 going in the box. That is different than if it would have been after the first hour, there's $50 in the box. After the second hour, there's 60 in the box. Okay, very slight wording changes the way we do the problem. But if you're adding this amount each time, like adding 50 to the box, adding 60, adding 72, if we want to know how much total is raised, we are, in this case, going to have to add those together. So we are doing a sum of the first 24. So the formula that goes with it, it's geometric. So our A1 is 50 times, what was that R? 1.2 to the n minus 1 power. And because we're doing a sum, we need sigma. If you had not used sigma, you would have been finding out the amount of money that he added to the box in that last hour. So just in the 24th hour. And we get 19,000. It seems way a lot, but the numbers do go up quite a bit. Okay, like the 24th term, like if he follows this pattern, in that last hour he added $3,300. So with geometric, those numbers get a lot bigger, a lot faster. Alright. I'm going to finish up. We're going to do this with last one because these questions do show up a lot and they're just they're a little bit different. We actually don't need a table. It's easier for us just to list out the first few terms. So it tells us right off that we are going to be finding a sum. So I already know that. We're finding the sum of the first 60 positive, odd integers. Do you know, first of all, what an integer is? It's a whole number. Okay. So do you know what it means for a number to be positive?
Above 0.
Above 0, like it's not negative. And then you know what an odd number is? Yeah. So let's list out the first few positive odd numbers. What's the first positive odd number? 1. What's the next one?
3.
And so on, yeah. So we're going to add, it says find the sum of the first 60 of those. So you have your sequence, 1, 3, 5, and so on. Fill out B, C, or B, D, and E. Alright, this is what you should have had. From 1 to 3 to 5 to 7, you're adding 2 every time. So it's arithmetic. There's your formula. The sum. You need sigma. You get 3,600.